So greetings to everyone. Welcome to Datagaps webinar. I am Pooja Gupta, Growth Marketing Manager at Datagaps, and I would like to thank you all for joining us today. Before we get started, we have a couple of quick housekeeping comments. First, we have muted all mics to avoid unintended distractions. Next, the chat room is open so that you can interact with us through the chat. And finally, at the end of the session, we'll open it up for Q&A. Today in this webinar on seamless migration to S4HANA, ensure data integrity through automated testing, we will share how Datagaps DataOps Suite would help accelerate migration timelines with testing automation and guarantees 100% data validation, consistent data quality, and trustworthy BI reports for reliable enterprise insights. On the panel today, we have David Small, Global VP of Sales at Datagaps, and Shubhanshu Dikshit, Product Manager at Datagaps. Here is our agenda for today's webinar. A quick overview of Datagaps DataOps Suite and how it helps overcoming migration challenges, wherein we will address the typical hurdles of S4HANA data migration with advanced testing automation techniques. Next, we will share how Datagaps DataOps Suite expedites migration speed. Thereafter, how Datagaps GenAI-powered data quality monitoring ensures trustworthy enterprise insights. Next, we will share how Datagaps DataOps Suite supports with ETL validation and BI validation at every stage of migration processes. Then Subhanshu will share the demo of Datagaps DataOps Suite, and in the end, it will be followed by Q&A session. Also, we have included a couple of polls which will reflect in the middle of the session, and we would request every attendee to share their feedback by answering those poll questions. And now I hand this over to Dave. Dave, stage is all yours.
Thank you, Pooja, and welcome everyone to Datagaps webinar. We appreciate your interest in Datagaps and the topic itself. What we're talking about today is really the migration process that you might consider and how you can test that migration process when you're moving from SAP ECC to S4HANA. Now, you probably know SAP has been around, ECC has been around since about 2004. They introduced SAP HANA, which was the database platform, in 2010, and then SAP S4 was introduced 9 years ago in 2015. So, there's been a long path and a long process that people follow to stay current with SAP. And there are tremendous benefits to moving to S4. Some of them have to do with real-time analytics. The data architecture is much more simplified. Improved integration with external applications is better. Cutting-edge AI capabilities. I came across these top 10 benefits from a company called IT Services 2. And they have a ebook that really expands upon this and talks about SAP migration from ECC, and it's really quite a good paper. They're not a partner of ours, but I've used some of their information because I thought it was quite good. So if you want to look at that in more detail, you can go to their site and download their ebook. Now, with all the benefits that you have moving to SAP S4HANA, there aren't as much migrations as they need. So Gartner still sees little evidence that the migrations are going to happen within the time frame of 2027. In fact, they say that only 36% of the people that have ECC have migrated or even subscribed to licenses to start the transition to SAP S4. So there's a lot of work to be done, and the time is sort of collapsing and running out. And so that's why we thought this might be topical for us to talk about how we might help expedite that overall process. Now, 61% of organizations hit data problems during those migrations as well. And that's sort of where Datagaps comes in, is to help you avoid and correct those data problems. So what Datagaps is all about is we focus on observing and validating the data pipeline from the point of ingestion through your ETL processes and all the way through to consumption in your data analytics platform. So we do that through a suite of products. ETL Validator does data quality checks, it does ETL validation, it does profiling, it does a wide variety of things. BI Validator gives you the capability of doing regression testing and performance testing, and a wide variety of tests on your data analytics platform, such as Tableau or Power BI. Data quality monitoring will monitor the quality of the data at rest within your organization, whether that's in your ECC environment or the S4HANA environment. And then we also create test data based upon sampling of your production data. So let me get into a little bit as to how that might apply in a migration. Now, again, ET2 provided this as part of their ebook and thought it was pretty good to step through at a high level the steps that you have to go through for the migration. And then what I'm going to try to do is layer in where Datagaps can help expedite things on top of these steps. So obviously the first step is to create the migration plan, but probably way before that is to get the management buy-in, the board level buy-in. I mean, these are long-term projects and very costly projects. And so having that buy-in and then creating the migration plan is crucial. Step two is really to assess the current systems and identify what processes you want to bring over, what customizations, what data, and a wide variety of things along those lines. And then step three is preparing that data and cleaning that data up to make sure you're not moving data to the new system that is either antiquated or error prone. And that's part of the step three process. Step four is really deciding, hey, what kind of approach are we going to take to do that migration? Is it going to be a greenfield approach where, I just start completely over in the new environment, or a brownfield approach, or a combination of the two, or a hybrid approach? And then begin the migration process, begin moving the data and making sure that all that data is tested to make sure it's been moved completely and properly. And then step six is, has to do with post-migration, getting people trained, getting people up to speed, and so on. So where we play in this with DataOps Suite is that in step two, we can help evaluate the data quality of your ECC data that's being moved into S4HANA. So we have the capability out of the ETL validator to do data quality checks. And as that data is moving, we can validate that data is properly formed. There's not nulls where there shouldn't be. Dates are properly arranged. And if you have to change the format, we can help you with that process as well. We can also profile the data that's sitting in your ECC environment. And through that profiling, you get all kinds of metrics. You get about 20, 25 different metrics on each data element. So you can understand where what the data is, like the minimums, the maximums, the distinct counts, all kinds of information gathered during that profiling. And that way you get a high level view of the data and what you have in each of the tables in the ECC. And then again, the data quality checks before loading. So not only can we evaluate the data quality of the data in ECC, but as it begins to move and get loaded into S4HANA, then what we can do is do data quality checks before loading into the new environment. In step three, we can help validate the old and the new ETL processes. So, you have an ETL process that's feeding potential data warehouse in the new environment, and that's feeding the old environment. Now you're going to produce a new ETL process that's going to feed the new environment for your data warehouse. We can help validate the old and the new process that they're producing the same results or the appropriate results, and we do that through ETL Validator as well. In step 5, if you like, we can help create test data so you can test the new environment. And that's based upon a subset or an extraction. And what we do is we create synthetic test data that you can load and test your SAP and S4HANA environment. We can validate the data between ECC, SAP, and S4 by taking snapshots and comparing the data between the environments to ensure that the data, again, was all loaded properly, that if you've moved your invoice table into S4HANA, then yeah, it's been moved properly and consistently and it's formatted correctly and so on. So we can help you with that validation that the data has been moved properly. And then again, test the BI platform. So as you have your data analytics platform executing against your data warehouse in the that is fed by the ECC environment, now you have that's being fed by the SAP S4HANA environment, and we can validate that the reports are running, that they're running the same, they're getting the same results, or you can do regression testing, all kinds of other testing of the new environment with the technology. So with that, that's my part of the presentation. What I'd like to do is hand this over to Shubhanshu and have him start the demonstration.
So firstly, thanks a lot, folks, for joining in today. In today's discussion, we will start with our main focus, which is how exactly we validate the migrations of multiple objects between ECC and S4HANA. And then, of course, the consecutive actions one must take because of this inherent change within their ETL or ELT pipeline. The diagram you see is what we're going to go through. In fact, we have a very similar diagram with the same set of validations that I've prepared, which I'll be showcasing towards the end of this particular demonstration. Note that this is a webinar demo, so we won't be getting into too many details of how exactly the application works. However, for that, we can have questions defined, and of course, our tailor-made demo for you and your team specific once we have a discussion for those. So first, let's start with our base use case. We see that we have a migration use case. As you can see, we're shifting in from ECC to H4. That being said, the vendors on this particular front aren't going to change, but everything else will. Even if you're talking about something called a white field or a brown field migration, where the assumption here would be that there are not a lot of tables which are going to be shifted around. Even at that point, you still have to deal with updated ETL logic and updated warehouse systems as a whole. So the migration process is not going to end just at the ECC to HANA shift. It is going to be after those corresponding shifts, the warehouses, the ETL transformation logics, and of course, the final aspect, which is the BI tools themselves. Making sure that the migration has happened correctly on all these steps is critical to ensuring a proper migration shift has taken place. And we'll be discussing all of these different points as well. So first, let's showcase the product and see where exactly we come in. I'm going to start with the very first screen of sources, and we're going to use the screen to elaborate that the application has inherent support for a lot of corresponding data sets. This could be your typical JDBC connectors. This could be flat files, complex files, APIs, as well as BI tools as well. The BI tools aspect is going to come in handy towards the end of the demo. Of course, our focus for today is going to be the S4HANA, which we have inherently present right there, and any other tool set as well. ECC and other aspects can be connected using the corresponding drivers, either using the given driver or using the generic connection, API connection, or in case what we have done with a good amount of our clients, a CData connector. So the main aspect here is that the application can easily connect to any specific data source, and if it does not have inherent connectivity, the application can create connectors for the same. One other thing, since we are here, let's wrap this one out as well. The application is Apache Spark based. What this implies is that for the application, scalability is not really a concern. We're horizontally scalable. And so within our examples as well, we have worked with really large number of data sets with high throughput. However, the more important aspect here is that the application can be installed directly onto your infrastructure. If you're dealing with any kind of financial data or PIS specific data, which requires you to not really put these data sets or reports out of your specific safe space or behind your firewalls, the application itself is agnostic and can be installed directly onto your infrastructure, be it an Azure system, an AWS system, maybe an on-premise system as well. Even Google Cloud is supported. So that's one of the key factors I wanted to flash up before we get into the specifics right there. which is that the application can be installed in your environment without worries of any kind of compliance. There's a good chunk on the compliance and security as well. The application is regularly pen tested, and we are audited by not just AWS and Azure, as we are on those marketplaces, but also a lot of private entities who are technically our clients as well, which also include a couple of federal clients, just to name a few. So with that, let's get into the actual use case. One last point here. Since we are Apache Spark based, any examples which I use, say in a particular example, I use SQL Server. Well, SQL Server can easily be replaced by Snowflake, Teradata, API systems, XML files, or anything in between. For the application, all of these connections are the same. With that, let's check our very first type of validation, which is the data-to-data validation between ECC and SAP HANA. So to quickly go back to our diagram, the process that we are looking at is the very first process without the data quality rules present. And what we are going to cover is comparing the data sets and corresponding measures. With the diagram side by side, you kind of understand what we are trying to do here. You're trying to pick up an object from SAP HANA, and doing this is quite straightforward. All we have to do is define it in our properties, define if we're pulling an object or multiple, and then pull the data set accordingly. And then we do the exact same system, except instead of connecting to a SAP HANA system, we connect to our ECC system. Once again, if needed, you can define queries depending on the driver that you're using, and you can pull out the exact target objects as well. Then the application can perform a data comparison between the two. Before we jump into the actual results, let's discuss a bit on what exactly this entails. Of course, what we are looking at is an object example. You're going to look at thousands of tables, or even hundreds of thousands of tables, depending on a use case. So automation here is going to be key, and that's something we will cover as well. To cover the basics at the start, we're looking at an object-to-object comparison. And within this particular example itself, there are a lot of problems that you might encounter as an end user. First one is quite straightforward. You're going to face a lot of data type mismatches between the objects. The application has inherent ways of handling that. You're also going to encounter issues where the number of columns between data sets might be uneven, might not be a correct match there. You could also face the problem that the column names between the two could be different as well. The application handles all of these issues and more within the application inherently. A good chunk of this is done using fuzzy logic, which you have complete control over. This implies that within this example, if I was working with country underscore ID and maybe just country ID, or say country underscore national underscore ID, because the column names are similar, the application understands that it has to map these two columns one against the other. Also notice that the inherent data type mismatches are handled by the application inherently. Of course, if I'm expecting some sort of thresholding or rounding off, I can define that within our thresholding section as well. Finally, the application has segregated the good and bad records for me, and the entire graph pie chart that we see on top tells the story, which is about, well, it's a 99.9% match, so most of our systems are perfectly fine. There are a few mismatches, and instead of going through the entire column list right here, I will go to column-wise mismatches, and it's going to tell me exactly which customer ID has what exact problem. And we see it's a good chunk of problems with a few spelling errors at some points, maybe some different customer name differences and other aspects that I've got. Now, this particular data set right here can either be saved as a file, it can be sent out as a report, it can also be raised to create Jira tickets or Slack tickets automatically at this point. And that's one of the key systems. The application is not just telling you what exactly is wrong, it's giving you the data set of what's wrong. So from this point on, you can choose to create your subsequent reconciliation use cases or notification use cases or ticketing services as well. The application has plugins and connectivity to all of these. Of course, the story is not completely over here. We see that the application has also found something called only in B. We go 11 records, but what these signify is pretty critical. You see, there are 11 records which are present only in our ECC object and not in the corresponding HANA object. And so the application has captured those specific records as well. And once again, these are data sets in itself. So if I would like to, at this point, let me just illustrate with a simple SQL. If I would like to just say pull the incorrect records and maybe fix them, I can just define that. Let's say add absent records as one set of SQL node that I want to add here. And if I would like to do that, I can just work with only in source in this case. Sorry, only in target. And then I can choose to write any SQL logic, Python logic, Scala logic, or anything in between to make sure I can perform the specific action. So in a way, if I want to do this, I can do this inherently with any tool sets that I would like. The application does provide a good amount of tool sets for me inherently. Quickly finish up our example, and to finish up what I said earlier, say if I want to raise a Jira ticket in case there's a mismatch present here, all I have to do is add a Jira ticket. Let's say Jira ticket raised. And all I have to do is search for a corresponding plugin of Jira ticket. There we go, raise Jira ticket in case there are differences found. So the corresponding parameters are needed, and I can just define and create a Jira ticket automatically. The list of components that you see, plugins right here, this can be expanded as well. In fact, since the application supports inherent Python and Scala coding, you can create your very own plugins as well. And this is what makes our product particularly powerful for any framework to be replaced with this particular, because the existing framework can be inbuilt within the application, and existing code can be easily reused across multiple examples. That we covered our very first aspect, which is, well, we can compare objects one against the other and we can perform simple comparisons. But let's make the statement a bit more realistic. What we have noticed with a lot of conversations from a good chunk of our clients is that like-to-like comparisons, which is where an object is converted as is between ECC and HANA, is a little rare in adherence to the policy that they would like to have lesser tables in HANA now. The main difference here being that from moving from ECC to HANA, we understand that ECC had a lot of tables and was really complex. And so in the sake of simplification, HANA is now going to have much fewer tables. What this means as an end user is, of course, it's much easier to work with those fewer amount of tables. But as a person who has been made to actually create this validations right there, it means that you can't just get away with simple select star queries between the two. And that's what our next example is focusing into. In our next example, you'll see that the application is pretty straightforward, and we are doing exactly the same thing in our S4 as well, which is picking up the actual table as is. But in ECC, we are performing a basic query where we're combining multiple tables. Here, I've gone with a hyper-simplified use case of a single table being combined one against the other. However, you can create your very own corresponding logic to pull them together. The best part here is that the application has recently introduced generative AI capabilities. And the way we implore our end user to use them is in this particular example, which is if you have a mapping file, and this mapping file could be akin to any specific mapping file that you're looking for, which has the logic associated with them, the application has the capabilities of ingesting multiple mapping files together and creating this test case automatically, including the query associated here. A caveat that we do have to mention, since we are talking about generative AI, is that the accuracy of this within our testing scheme is about 80%, which includes a combination of very simple mid complexity and really complex transformations. And as you can imagine, the very complex transformations is what requires a couple of resets. So the application does get there, but it requires a couple of resets, and we are planning to improve that as well. But from an end user perspective, imagine just putting up a good chunk of the documentation that you have lying around into the application, and the application creating these test cases automatically, which connect to multiple tables in the source, connect to the table in the object and target object as well, and then run comparisons once again. And in here, we see, okay, there are still mismatches found, and the application has segregated those mismatches once again. We see that our customer table seems to be perfectly fine, but when we combine the sales table and we compare these two, then we see that there's a bit of difference between the two, and the application has captured that. And that's one of the key factors of what we are discussing so far. So far, we're discussing the aspect of a like-to-like, but this example now pushes the boundaries further into having a like-to-unlike match as well, where you have multiple tables being combined together within the source, and the target object being the representation of this, and the application ingesting files directly to create this combination logic. A quick illustration of how easy it is to do. Well, all you have to do is get into the system, create generate data flows, and the application is going to give me multiple options on defining exactly where I would like to run this. Of course, this is not our first rodeo. We have multiple use cases for this. And you can do it between any two different types of JDBC connections as well. And the application can work with importing Excel files or importing datasets directly if you're going for a like-to-like comparison. For the sake of time, we won't get into this too much, but the basic gist is that the application is capable of creating this entire plethora of test cases altogether. Let's go back to our example and illustrate what are we missing at this point. So at this point, what we have done is basically just one type of validation. We've ensured that our objects between our ECC systems and S4HANA systems are compared correctly. Of course, there could be an added caveat where we would like to compare measures, but that will come in the upcoming sections as well. There's the other aspect of ensuring that the transform logic is now correct. It would also be that the warehouse that you're working with needs to be validated. So let's discuss about these two. Regardless of what warehouse you're working with, even if you are not changing warehouses, there are going to be differences incurred because of because of the migration that's been happening between ECC and S4. I mean, the question that we posed at the very start, which is, well, now that multiple objects are being combined into one, is going to have dire effects on the entire transformation and warehouse. So, well, what do we do at this point? Well, we take the output of the ETL logic itself and run comparisons between them. So far you'll see that we're going with comparisons and we're skipping rules for now. We'll get into this shortly as well. But here, for this sake, let's open up a simple example. And here, my assumption is that we're working with a SQL Server and a Snowflake system. So you'll see the application is pretty uniform in that particular use case, where my on-prem SQL Server, this is the output of my ETL logic. Now we're working with some dimensional tables itself. We're picking this up from the legacy system and comparing them to the updated warehouse. The same object, except it's on my cloud Snowflake system. This could be something that could be part of whitefield conversion approach, where you're actually trying to update not just the S4, but you're updating other systems as well. So you can see why this is particularly important. And once again, we perform a basic comparison to ensure that the corresponding data sets have been transferred correctly. Here we notice that, well, there is a good amount of transformation, and this is a higher score than we got earlier. However, there are higher set of records which are present only in our legacy system, which are not transferred correctly, implying the issue within our transformation logic itself, defining that these particular records are outliers in that specific use case. Of course, we finished this particular this particular test case up by creating a ServiceNow ticket. This is just to illustrate that it's not just one specific tool like Jira that we integrate with. We integrate with a lot of CI/CD and DevOps tools. Before we jump into the main use case, let's have another small check on what we are trying to do. So far, we are trying to work with data sets. I mean, that's what you the select star system in both our systems. However, there could be a use case, especially in whitefield approaches, where the data sets are going to be different, but what you're concerned about are aggregations. Let me illustrate what I mean by an end-to-end example here. The example in question works with measures. So here what we have is a very simplified use case of what we discuss as a production monitoring system, where you have multiple layers. But what I want to focus on in this particular example are the bottom layers, the silver and the golden layer. What these represent are the corresponding migration use cases where data sets are going to be inherently different. However, the aggregation between them needs to be uniform. What we mean by this in this particular use case is that instead of going for a comparison of just the raw data, we are comparing and we are going to compare the aggregations in between. I understand that between my migrated data source and my legacy data source, or in this case, warehouses, the data sets and the structures are going to be different. However, this does not change from the fact that the overall aggregate that I'm working with, it could be the sum, it could be averages, it could not be volume in some cases, but the averages of what I'm working with need to be in sync with each other. So here, instead of going with a data comparison, what we are discussing is a measure comparison. Instead of comparing raw data 18K records, we worried about just 6 records between 2 distinct layers on between 2 distinct sources, here SQL Server, and in the other case, we are working with a Snowflake system. And here, the comparison is to ensure that these aggregates match. So this is another approach, depending on your specific use case. If you go with the brownfield system, this is not exactly something that might be needed. However, this is something that's a good thing to have within your arsenal of tool sets as a QA developer or a QA tester, which is ensuring that you can run validations not just for overall files, but after some transformation between them, just to ensure that these particular systems work in this particular manner as well. Now that we've discussed the 2 specific aspects, let's go back to the final system, which is the BI validation, and let's see how the application looks from an end-to-end perspective. So this particular test case combines everything that we have seen so far and adds a couple of things on top. Let's see what's happening. We're tracking the usage of one particular data set between the 2. Here, the data set in question is, of course, DIM customer. We ensure that this particular data set has been migrated correctly between ECC and HANA and run validations between them. We capture any differences between them, as we can see. Then we ensure that we do a similar kind of validation between the legacy warehouse and the new warehouse table. So we do that right here as well. Once again, we find the corresponding issues where we have seen that the legacy warehouse has a good amount of records which are not found in the new warehouse, indicating that there are transformational issues or there are issues present within the logic of the tables itself. So we capture that inherently and notify the end user. Of course, you can choose to fix these records and add them back into the corresponding new warehouse. That could be a use case for as well. And the other 2 new things that we're working with. You see, comparison in itself is pretty great. However, since we are working with new systems, it's important that we run a good amount of traditional checks as well as business rule checks. What I mean by this are checks in terms of, well, making sure that a primary key is not null, making sure that the primary key and the foreign key between tables does not create any orphan records, making sure that a particular composite key does not have duplicates, making sure that a particular address column, which was originally, say, about 50 characters long, is not crossing that, or making sure that the actual aggregate that we have created, since now we are working in a warehouse, we want to ensure that these aggregations, in this example, it's represented by yearly income, this is in the expected range. All this and much more can be defined by the end user. All the rules that you see here, once again, can be created using generative AI as well. And once they're generated, you can easily import them and export them across multiple tables and systems as well. In fact, if you're looking for an easy way to run validations between your dev and production environment, it's as easy as defining if you're working within your dev and production environment right here as well. All of these are just quote-unquote tip of the iceberg moments of the application features. All these features have a lot of intricacies between them and a lot of customizability that the end user is allowed. We do not believe in blocking the end user of specific customizations, because if that's your use case, we would like to enhance it and make sure you can reuse it as many times as you would like. Example in point, if I'm working with a very specific type of validation I would like to do for any specific type of column, I can create my very own operators to run this particular type of validation. Is not money or decimal is just one of those examples one of our clients had. They wanted to ensure that any kind of claims related data set, which is any kind of financial data, is does not really have a decimal point, does not really have a currency or any commas between them. Simple rule, but when it comes from a regulatory body such as a government system, it is subject to change. And you'd like to ensure there's an easy way to change it and apply it across 50 data sets. It's as easy as selecting this and voila, that's all you have to do. Just an example, but of course it goes much deeper. The end result is that the application does catch any kind of issues found, which is not just comparison or reconciliation based, but also quality rule based. You can also run comparisons in terms of profile and also define machine learning based anomaly detection for the same. All this and more can be covered in the data quality aspect of our product. Now, to finish up the use case, especially for the directors and anyone who is actually looking at the results of this particular migration, the BI use case. Let's open up the system and illustrate what we are trying to do. Well, you'll see that the application here is looking at two distinct reports. These reports are the legacy report versus the newly updated report. Even if you're working with the same platform, or even if you're changing platforms, say you're moving from Tableau to Power BI, the application has the capabilities of capturing any type of visual changes, data changes, as well as catalog changes, the metadata changes of a report, which are filters and other aspects. As you see here, once I zoom in, the application has captured differences between the two, which is really expected given that our entire migration was filled with these issues. But these issues are between 3.3 million and 3.1 million for a particular data set. Additionally, we see for some of ship mode, some of sales by ship mode, there's an entire aspect of same day which is absent in our newly found report. So the application has captured that, along with any kind of changes they find in the system. Of course, there's one other subtle change that you might not have caught. Let me move into appearance and just highlight it specifically here. Moving back into some of sales by ship mode, we'll see that the title of our corresponding visual in this case has been shifted from center alignment to left alignment. And all this can be done across the entire dashboard. What we are seeing is an example for one specific report and how exactly the metrics in these reports are being tracked moving backwards. But the same thing can be done across multiple reports of the entire dashboard as well. In fact, that's what this example is privy into. If there are any filter differences or any other specific aspects, the application has the capabilities of capturing them as well. If some filter was defined as complex in the legacy system, but that filter is not defined as complex in the new one, the application has capabilities of capturing those and highlighting them to the end user that, well, in this particular case, there's a logical operation needed, which is present in the oldest version and not in the new one. Not to mention that we're also running performance checks in the same time to ensure that the loading times of the new reports after these data sets have been migrated are also being validated. So in this particular fashion, the end user can see everything in a nutshell. And especially with such a type of case that you're seeing, the user can actually track back and see exactly what has gone wrong. Let me illustrate this further. If I go into run history, this is done for each and every use case. And if I go into our customizable reports, at a glance, if this particular test case has failed, say this particular data set or object combination has failed, I get an entire report stating, hey, exactly what happened between my SAP migrations. All right, these are the records which are incorrect. For a closer look, I can switch into column-wise mismatches. That's pretty good. What happened to my warehouse migration? Well, everything is clubbed together as well. It's easy for the end user to understand where exactly the problem statements lie. And if you're working with a developer, or if you are the developer, as might be the case in a lot of use cases, you can also find out the issues right there as well. Knowing that in this case, well, I think I messed up a condition within the first name logic of my transformation, and I can go back and fix it easily. And the best reason why this kind of layered approach is important is that sometimes if you find some issues in your BI layer, it's very difficult to understand where exactly those issues came from. However, if you're tracking these issues across multiple layers, it's very easy for the end user to understand where exactly the problem lies and which exact transformation the problem lies into. Note that all these discussions that we're talking about are talking from a perspective of migration. However, a success story that we have seen quite often from a lot of our clients is that a migration turns into production monitoring use cases as well. So if you have some set of rule sets, the thing that we discussed earlier, if you want to reuse these rules, you can easily reuse them between your production monitoring use cases, cross-environment use cases, and cross-platform use cases as well. So a lot of the aspects that we have discussed can be easily migrated to ensure that any work that you've done within your migration system is being performed within your production monitoring systems as well. All this with the aspect of the product that can be integrated with, say, Azure DevOps, Jenkins, Jira, Slack, or any other type of ticketing or notification tool. The application does have bidirectional support for that. And this is just, once again, a small part of what the product can actually achieve in this case. Here we looked at just one particular data set and its journey throughout the entire system, but you can extrapolate from this how the entire application might look when you're looking at things from a wide-eye perspective. Let me give you a glimpse on what that feels like. Had a similar use case, except we were working with a dashboard front perspective where we want to ensure that the entire dashboard is correct after a migration. So we did something similar in this particular use case. And the application has kept track of the entire dashboard. And here the application has created a proper system for me to understand exactly which aspect of my dashboard has failed and what all other aspects are correct. The application has correctly defined the report for me. And in this case, I'm actually seeing from a report first perspective. I can do a data first perspective as well, exactly what's incorrect within my reports and between my systems. Everything is laid out for the end user to understand and comprehend. So even if you are someone who is the end business user of this report, once you see this, you will have the confidence that yes, not just by migration, but also the corresponding transformations, logic, and the corresponding warehouse, and even the BI reports are correctly validated from an end-to-end perspective using the toolset. All the test cases that I've worked with so far can be created automatically as well. Everything is exportable. There's programmatic way to create the test cases, which is if you want to let go of just the drag and drop system and just want to code in the test cases, you can do that as well. We have extensive functionalities such as parameterization, cross-environment running, and inherent kit functionality as well. Which is if you like to treat your test cases as code, we like to do as well. And so this is very easy and good for the end user to define a true CI/CD. Because if you want to work with true CI/CD, you need to make sure you treat your test cases as code. Yes, and with this particular test point, I would like to actually stop at this point. We'll see if there are any other questions. And this is where I'd like to stop the demo. And just with the pointer that the application has a lot of other features as well, apart from the test plans, the integration with DevOps tools, the integrations with other systems, and it has a good amount of inherent tool sets as well. So with that, I'd like to, well, firstly, thank you for listening in so far. And if there are any questions, we can have them right now.
Sure. So, Shubhanshu, we have a question that by what percentage can your automation tools improve the efficiency of our data migration testing process compared to manual testing?
Well, we don't really have an exact number, as you might imagine. However, we have a good amount of case studies that we've done. And in most cases, the case study numbers lie around 40 to 50%. It's half. I mean, the thing is, it goes variant depending on the exact technology use cases. But an automated solution has decreased TPO by 30% on an average, decreased the overall testing time by at least 40% in a lot of use cases. I mean, one of the biggest examples was a pharmaceutical giant used our application to reduce their testing time from months to days. That's right, from months to days, especially with the upgrade test plans that we have. So, I mean, we have a percentage. It's quite varied depending on the case studies, but we have all the case studies within our website. You can feel free to reach out there. And of course, reach out to us if you're looking for a very specific use case that we might have encountered in the past.
Okay, so next question is, what level of accuracy can we expect from your automated data migration testing solutions?
Oh, that's an excellent question. And the answer is 100%. So when we talk about migration validation, let me just open up the test case. We are making sure we are running validations on each and every record, even if you're working with 1 million records. I mean, we went close to that in one of our examples of multi-object, where the actual validation is a pretty high number, given that we're working on a very small cluster. But hey, that's the main point, that the application has horizontal scalable clusters that can auto-scale with Kubernetes, AWS EMR, or any other system as well. So even if you're working with really large volume sets, the application has the most efficient way to ensure each and every record is being validated either by a different record, basically a source of truth, or against rules. All of our testing is 100% validation testing, where we basically ensure that each and every record is being validated.
Thanks, Shubhanshu. Another question is, do you support SAP S4HANA on public cloud?
Yes, we do. It's just a driver aspect for us. So even if you're working from an on-prem system or a cloud system, the application has the support for that.
Next is, are your automation tools compatible with different data formats and sources involved in the migration?
Once again, a really good question. Yes, the application does have the support of multiple data sets. Going back to this particular screen right here, all of these data sets are inherently supported, in addition to the corresponding data sets which you might get using CData connectors, generic connectors, and API connectors. And this also includes complex hierarchical files. So if you say working with an XML system, maybe you're working with an IBM DB2 system, the application has the inherent support for all of them. And since, again, it's Spark based, all of these are Spark data frames. So if your solution works for one platform, say SQL Server, it can easily work for any other system as well.
Thanks. So these are the all questions, and someone asked that since he joined late, will this be recorded and the link will be shared? Yes. So the link will be shared. It is all a recorded version. Thanks.
Over to you, Dev. I think we can end it from that.
Yeah.
Yeah. Well, first of all, thank you everyone for attending. We're happy to do a custom demonstration or have a discovery call with you and your organization to find out if some of this can apply and help you save time in your migration processes. And we also offer proof of concepts and a variety of other things. So with that, I would again like to thank everyone for attending, and we look forward to hearing from you in the future. Please reach out if you need something. Thank you now.
Thanks, Dave, for a complete understanding of DataOps Suite, and Shubhanshu for an extensive demo for the same DataOps Suite for automated testing of data migration projects. So if you have any further queries, you can always reach out to us at contact@datagaps.com. Thank you, everyone.